Hi folks, we're going to take a look at page 364, number 20. So here they give us two forces um, that have an angle between them of theta. Okay, so that's why they're drawn tail to tail. And they want us to show that the magnitude of the sum of these forces is going to be given by this expression here. Okay, so hopefully the first thing you notice is that this looks a lot like the cosine law, yet why is there a plus sign in there instead of a subtraction? All right, so what I'll do is I'll use my diagram to see, how I might possibly be able to show that this would be, in fact, the um, uh, expression that's going to give me the sum. So of course, the first thing I notice is that these are placed tail to tail, and if I want to add these two vectors, the first thing I'm going to do is move this vector over so that it's tip to tail. So I'm going to draw here vector F2 and then draw the sum. So right away, the vector F1 that I'm moving over, and this now becomes F1 plus F2. Okay. So as we know, when we're doing this, the angle that's given between the two vectors is not going to be the angle that we're going to use to solve the problem, okay? Because we need an angle inside the triangle. But of course, we know that as I moved over vector F1 over, these two are parallel. Hence, we can use the parallel line principle. So this acute angle and that obtuse angle are going to have to be supplementary. In other words, this angle here is going to be 180 minus theta. Now, of course, remember that when we're trying to prove that two sides are equal, I'm going to start with one and then show, hopefully, by doing some manipulation, that it's equal to the other side. So given what I know about adding vectors, I'm going to start with the left-hand side here. Okay. So I'm going to use the cosine law to determine an expression for this sum, because here I've got these two vectors F1 and F2. They were given to me in the diagram. I have an angle that I can use inside the triangle based on the angle between them, which is something that was given. So even though they're not, I don't know the exact values, they were the given values in this problem. So let me just apply that here. So of course the cosine law tells you to take the sum of the squares of the other two sides. Now again, make sure you're not squaring the vector F1. Okay, we don't have any sense of what that would even mean. What you're squaring is the magnitude, okay, plus the magnitude of the second vector minus 2 times those side lengths. Okay, so again, magnitude of F1 times magnitude of F2, okay, times the cosine of the angle opposite to the length that you're looking for. So the angle opposite to the length we're looking for is not theta, it's 180 minus theta. Okay? So this is the expression that gives you the sum of the two vectors. The question is, how in the world is it going to be equal to that thing up there? Well, this is where you need to have to recall something that we would have seen back in advanced functions. Of course, we would have seen this when we were working in radians, but radians, degrees, are just a change in units. They don't actually change the all those things that we showed. And hopefully you remember that if you take cosine of pi minus some angle theta, okay, which of course pi is equivalent to 180 in radians, we had shown that this is equal to the negative of cos theta. And sort of a quick recap is, if this is my angle theta, and then here I take an angle pi minus theta, you see that when I create my similar triangles, they're exactly the same, except the x value here, which is what I would be using for this expression, is negative as opposed to positive. So that's why the cosine values are negatives of each other. But from here, we can say that cos of 180 minus theta, when we're working in degrees, is equal to negative cos theta. And so this is what we're going to do. We're now going to input this into that expression. So here I'll actually show all the steps, a little bit of writing, but nice and easy at this point. So this now can be replaced by negative cos theta. And of course, now I'm subtracting a negative expression. It's going to become an addition and give me exactly my right-hand side. Which again, here is just the right-hand side that I was trying to prove. So first of all, let's recall that when I'm trying to prove that two sides are equal, can't be making any assumptions. I have to start with one side and then manipulate it. Hopefully I can manipulate it so that it equals the other side, which is what we were able to do. But here we're starting to see how all those tools that we developed in previous courses can come in handy sometimes when we might not even expect them to. But the idea here was to recognize that because you were adding these two force vectors, you needed to move it over to place them tip to tail, and the angle you were working with was 180 minus theta and not theta. Okay, that's it for this one.